AP Chem students, this is an example problem for you working with Ka and pH for acid-base problems. In this particular problem, you have a 0.020 molar solution of niacin that has a pH of 3.26, and you are needing to find the Ka for niacin. This is what niacin looks like. Its structure, you have a benzene ring with a nitrogen in place of one of the carbons, and then you have that COOH that is typical of carboxylic acid. So anytime you see the C double bind O and then OH, that's a carboxylic acid. This is just a particular one. And you see that there are actually several hydrogens in this compound. One is attached to the oxygen in the carboxylic acid, and then there are actually 4 that are unwritten that are sticking out of that benzene ring, the carbons that are at the vertices of that benzene ring. The hydrogen that is attached to the oxygen in carboxylic acid, the COOH carboxyl group, is the one that is acidic. That's the one that's going to come off because the oxygen-hydrogen bond is polar. So that oxygen and then, of course, the other oxygen in the double bond, they'll be comfortable handling, because they're pretty electronegative, comfortable handling that extra electron when the hydrogen ion goes off in aqueous solution. The hydrogens that are part of the benzene ring, that are attached to the carbons in the benzene ring, are not going to be acidic at all because the carbon-hydrogen bond is not polar. So that's what niacin looks like. We're going to talk about a system that you're going to use. The first thing you're going to do always in anything in chemistry pretty much is to write the balanced chemical equation for what's happening here. So you have an acid. This is a weak acid clearly, and it is going to dissociate into its conjugate base and the hydronium ion, making sure that you are balanced for mass and charge always. The system you're going to use is basically this. You're going to write the balanced chemical equation. You're going to do a Rice chart of some form. You're going to think about what you know about pH, and you're going to think about what you know about Ka. Every problem is going to be variations on this theme. So this will be your system that you can use, and then the specifics are just going to depend on your particular problem. But this way you know how to dive in. You know how to start. Write the balanced chemical equation for what's happening. Then you're going to do a Rice chart, kind of evaluate what you know and what you don't know. First thing is you're given that 0.020 molar concentration of niacin. That means that that is the initial concentration. What that means is that if you had a liter of water, what they did to make this solution is they took they measured out 0.020 moles worth of niacin. So niacin has a molar mass. Convert that to grams. They measured out that many grams, and then they added water until you ended up with a liter of solution, for instance. This number will be true whether you have a liter of solution or 100 liters of solution, just using that as an example. So that 0.020 molar is describing how the niacin solution was created. It is not telling you the equilibrium concentration of niacin. It's telling you the initial concentration. How did you make that solution? And then, of course, the change would be minus x. The equilibrium would be initial, and then minus the minus x for minus change. H2O liquid you can cross out because that's a liquid. It will not appear in the equilibrium constant expression. Then you have zeros for initial concentrations of the conjugate base and hydronium. Hydronium, technically, even in water, you have a little teeny bit, but it is negligible. If you had pure water, of course, it'd be 1 times 10 to the negative 7 molar, but that's very, 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 very small. That's just 0. The change would be plus x for both of those. 0 plus x is just x for the equilibrium. So you've written all this regardless of what you're even solving for, right? This is just a setup. You write the equation, you evaluate what you know, and in your Rice chart. Now what we're going to do is think about what we know about pH. We are told the pH is 3.26, and we know pH is negative log of hydronium concentration. So what that tells us is that we can find the hydronium concentration at equilibrium. Very important. This is the hydronium concentration at equilibrium is 10 to the negative pH, so 10 to the negative 3.26 in the calculator, rounded 5.5 times 10 to the negative 4 molar. this is the equilibrium concentration of hydronium. Because the pH, 3.26, is measured with the pH meter, it's just going to tell you the hydronium concentration at that time that the pH meter is in the solution, which is equilibrium. These equilibriums occur, weak acid equilibrium occurs very quickly. So you put the pH probe in there, tells you the pH, that's telling you the hydronium concentration at that time, which is the equilibrium, state. So next we also know that that is in fact X, because the hydronium concentration at equilibrium was X. We now know the hydronium concentration at equilibrium, so we now know X. X is 5.5 times 10 to the negative 4. Next step is to write the Ka expression. Products over reactants raised to the power of their coefficients, putting brackets around them to indicate that those are concentrations, and also very importantly again, equilibrium concentrations always in a Ka expression. This is an equilibrium constant expression, it's just a particular one for an acid. We now know that that's X times X over 0.02 minus X. We know what X is, so we can put the numbers in, and then we can just put that right in the calculator. No units, of course, for Ka. So let's just recap that quickly. Ka is just like any other equilibrium constant expression, products over reactants raised to the power of their coefficients. From your Rice chart, you know that the concentration of both of those things in the numerator is just X. So that's X times X is X squared. The denominator is the equilibrium concentration of niacin, so 0.020 minus X. Some of it, you had 0.020 molar to begin with. Some of it did go away, though, because it got turned into the conjugate base. So that's why we have the minus X. You know the value of X, so you can put that value in. Calculator, 1.5 times 10 to the negative 5. So that's an example problem when you know pH and you have to find Ka for that acid.